In this video, I'm going to discuss box plots. First, I'm going to give an example of a box plot. So in this example, we have math SAT scores for a random sample of 10 individuals. Right. So what are box plots? Box plots are a way to graphically represent this thing that we call the 5-number summary. So first, let me go ahead and write that down, what a 5-number summary is. 5-number summary. All right. So what is a 5-number summary? It's the min, the first quartile, the second quartile, the third quartile, and the max. Okay, this 5-number summary is what we will use to make our box plot. Okay, so box plot is a graphical way to represent this 5-number summary. All right, so to find the min and the max, these are the easiest, right? This data is already sorted. So the min, smallest number, is 300. The max, the largest number, is 750. Okay, so now I just need to go find these quartiles, and then I'll be ready to graph this. Okay, so to find the quartiles, to find the first quartile, I'm going to use this equation. Remember this equation, L equals K over 100 times N, right? Where K is the percentile that you're looking for. So first quartile is 25th percentile, and N is the sample size. Okay, so for the first quartile, which is the 25th percentile, L equals 25 over 100 times 10. So that's 0.25 times 10, which is 2.5. And remember, when L is a decimal, you round up. So we go and we look for the third observation. So 1, 2, 3. This data is already sorted, so the third of a sorted data set, and this one's already sorted. So the third is 450. All right, so now let's go ahead and find the second quartile. Second quartile is the 50th percentile. Divide that by 100 times 10. So that is 5. Remember, when L comes out to be a solid number, a whole number, you have to take the average of 5 and 6. So here's 4, 5, 6. So take the average of these two numbers. Okay, so the average of 500 and 550, sum those up, divided by 2, you should get 525. All right. Lastly, the third quartile. Third quartile is the 75th percentile, so 75 over 100 times 10. So that will equal 7.5. Right? That is a decimal, so you round up to the next whole number. So that's 8. So 6, 7, 8. So the 7th observation is 700. The 8th observation is 700. All right, so I have my 5-number summary. I'm ready to go ahead and draw a box plot. Okay, so to draw a box plot, the first thing you should draw is the x-axis. Should label what this axis is. So in our case, it's going to be the math SAT scores. All right, then number the axis in a nice way. Okay, so we can start with maybe 300, and we can count maybe in 100s. So 300, 400, 500, 600, 700, 800. I guess I guess I need to go to 800. Okay, so you should count, and when you're doing your dash marks, there should be basically kind of like even intervals between your dashes on your x-axis, right? All right, so now I'm ready to go ahead and start drawing my box plot. So to do that, the first thing I'm going to do is I'm going to draw vertical lines for where each of these 5 numbers are. So here at 300, I'm going to have a vertical line. 550 or 450, I'll have another vertical line. 525, that's somewhere around right here, I'll have another vertical line. 700, I'll have a vertical line. 750, I'll have another vertical line. All right. Now connect the middle 3 lines to make a box. Okay, then make whiskers by connecting that box to the min and the max. Okay, so here's the min, here's Q1, Q2, Q3, and the max. Great, so there you go, there's your box plot. So it's just a way to visually see your 5-number summary. Now you can tell some things about the distribution of the data based off of the box plot. For example, this data may be slightly left skewed because of the longer whisker down to the min. So let's talk about that. What does different box plots look like based off of their distributions? Well, like a normal distribution box plot would look something like every interval would be about the same. Okay, so this distance is about the same as this distance, which is about the same as that distance, which is about the same as that distance. All right, so everything is really symmetric about a normal distribution box plot. Okay, so a normal distribution box plot would look something like this. All right, what about a skewed distribution? So we'll start with right skewed. Right skewed. So remember, right skewed means long right tail. So most of the data would be over to the right, right? And then you would have a really long tail out for where the max is. Okay, so most of the data is over here to the right, and then you have a really long tail over to where the max is. Okay, lastly, what does a left skewed look like? Looks pretty much like the opposite of a right skewed. So left skewed data set. Remember, left skewed has a long left tail. So we would have a long time to get to the min, then all of the data would be over here to the left. Okay? So you can kind of get a sense for what the shape of the distribution is based off of the box plot.